Hello everyone, this is Pratibha. In this video I'm going to discuss about random scan display and the subject is computer graphics and image processing. Let's move on to the today's agenda. Introduction to random scan display, principle of random scan display, advantages of random scan display, applications of random scan display, challenges in random scan display, emerging trends in random scan display, comparison to raster scan display, conclusion and future outlook. Introduction to random scan display. A random scan display is also known as vector display, is a type of display device that draws graphics by directing an electron beam to specific coordinates on the screen. Unlike raster scan displays which draw images line by line from top of the bottom, random scan displays directly draw lines and curves based on vector graphics. Key characteristics of random scan display. Drawing method. Random scan. The electron beam moves directly to the straight point of a line a curve and then to the end point, drawing the shapes in a continuous motion. Raster scan. The electron beam moves in a fixed pattern, scanning the screen line by line from top to bottom, which is more suitable for rendering complex images and textures. Image quality, high precision. Random scan display can render lines and curves with high precision, making them ideal for applications that require detailed line drawing, such as CAD. CAD is nothing but computer-aided design and technical illustrations. Scalability. Vector graphics can be scaled to any size without losing resolution. They are defined as mathematical equations. Flicker and refresh rate. Reduced flicker. For static images, random scan displays exhibit less flicker because they do not need to refresh entire screen constantly. They only refresh the draw lines. Dynamic content. For animations or complex scenes, the refresh rate can be slower, leading to potential flickering as each frame requires the electron beam to retrace all lines. Memory usage. Efficient for simple graphics. The memory required for random scan displays is proportional to the number of lines and shapes rather than the overall screen resolution. This makes them the memory efficient for images composed mainly of lines and simple shapes. Limited colors. Historically, this display supported an limited color range compared to modern raster display. Principles of random scan display. Line drawing technique. Vector drawing. Images are composed of straight lines defined by the endpoints. The display's device electron beam moves directly between these points, drawing the line sequentially. Stroke writing. The electron beam moves to draw shapes similar to how pen plots on the paper, which is why this technique is sometimes called as calligraphic display. Display refresh. Refresh rate. The screen must be refreshed regularly to maintain the image, typically 30 to 60 times per second. This is because the phosphor coating on the CRT screen fades quickly. Refresh buffer, also known as the display list, stores the commands for drawing each line. The display processor continuously cycles through this list to refresh the screen. Image quality, resolution independence. The quality of the images is not dependent on the screen resolution but rather than the precision of the line drawing commands. Smooth lines. Lines are typically smoother and can be rendered with higher precision compared to raster scan display. Hardware requirements. Display processor. A special purpose display processor is required to interrupt the line drawing commands and control the electron beam. Analog deflection. The electron beam is controlled by analog deflection, which is less susceptible to the limitations of digital raster grids. Graphics capabilities. High quality line art. Best suited for applications requiring high quality line art such as CAD and other engineering applications. Limited fill capabilities, less efficient at rendering filled regions, detailed textures which are better suited for raster displays. Interactivity, real-time updates, changes to the display list can be quickly reflected on the screen, allowing for real-time interaction and updates, crucial for interactive applications. Direct control. The display processor provides the direct control over the beam's position, drawing for dynamic and responsive graphics. Performance efficient for simple graphics. For images composed of a small number of lines, random scan display can be more efficient because they draw only what is necessary. Complex management. As the complex of the image increases more lines and shapes, the performance can decrease since the beam needs to travel all vectors in the display list. Legacy and modern use. Historical significance. Widely used in early computer graphics applications before raster scan technology became prevalent. Nike application. Still used in some Nike applications where vector graphics are preferred or necessary. This principle illustrates why random scan display were important in the early development of computer graphics and their continued relevance in specific applications today. Advantages of random scan display: high quality line art, smooth lines. Random scan display can render lines very smoothly without the jagged edges that can occur with raster scan display. This makes them ideal for applications that require precision and high quality line drawing such as CAD. Resolution independence, detail precision. The image quality is not dependent on the screen resolution but on the precision of the line drawing commands. This allows very detail in the line drawing irrespective of the resolution of the display device. Efficient use of resources. Minimal data requirements. Random scan displays requires less memory and processing power for simple line drawing because they only need to store and process the endpoints of lines rather than pixel information of the entire screen. Selective drawing. Only visible lines are drawn, making rendering process efficient of images composed primarily of lines and curves. Real-time interaction. Dynamic updates. Changes to the display can be made and reflected quickly, allowing for real-time updates and interactivity. This is particularly useful in applications like flight simulators and interactive design tools. Direct beam control. The display processor provides direct control over the beam's position, enabling dynamic and responsive graphics. Hardware advantages. Analog precision. The analog deflection of the electron beam allows for more precise positioning than the digital approximation used in raster scan displays, less susceptible to grid limitations. Since the beam moves directly between points, it is not constrained by the pixel grid, allowing for more natural and fluid rendering of lines, reduced flicker for line drawing. Stable images. For images composed mainly of lines, random scan display can be provide more suitable and flicker-free images compared to raster scan displays, which can be suffer from flicker due to the interlacing of lines. Specialized applications. Engineering and scientific visualization. Ideal for applications where precise and clear line representation are critical. Successful engineering, scientific visualization, and certain types of simulations. Vector-based graphics. Well suited for vector-based graphics and applications that really rely on geometric shapes and transformations. Applications of random scan display projection systems. Random scan displays are commonly used in high resolution projection systems such as those found in cinemas and large scale displays. Medical imaging. The high resolution and low power consumption of random scan displays make them well suited for medical imaging equipment like MRI and CT scanners. Specialized displays. Random scan displays find use in night applications like laser light shows, head-up displays, and specialized industrial control systems. Conclusion and future outlook. Continued research, ongoing advancement in materials, components, and control systems will drive further improvements in random scan displays. Expanded applications. As the technology matures, random scan display will find use in an increasingly diverse range of applications. Innovative designs, creative integration of random scan principles with other display technologies will lead to novel display solutions. Thank you for watching this video.